Good evening, Dr. Hammer. I am Amarnath. Today, my team has given me the honor to present them. To my right is Sai Madhav, and to my left is Shivkant Lanka. The project today we are discussing today is a fundraising mail campaign for PVA, and in the next couple of minutes, we'll take you through this presentation. Uh, we'll discuss, me and my teammates will discuss about a little background about PVA and what we are trying to do in this project and why we are trying to do this analysis. And my friends will they walk you through this data preparation and data cleaning, what we have done in this project. And uh, finally, my friend will give you what are the models we have built and a little details about the models. So, Paralyzed PVA, Paralyzed Veterans of America, is a not-for-profit organization that provides programs and services for U.S. veterans with spinal cord injuries and diseases. It is a not-for-profit organization which sends mails to people for collecting money. Uh, so they have an in-house database of over $13 million, and every year they send out these mails to potential donors, and they collect revenues which they'll use to help the veterans of America. And this year we're trying to maximize, because sending each mail to a donor, potential donor, costs 68 cents to the PBA. So we're trying to minimize the cost of sending a mail by predicting who is likely to donate and only sending those targeted mails. So in this process, we are trying to eliminate the email sending cost and maximize the returns. So this is one of the particular group of people we are trying to send this mails are lapsed donors who are uh, who have not donated in last 12 months. So last 12 to 24 months. So we are trying to send a mail to them and remind them of PVA so that they'll uh, repeat the donations. And, the goal of this project is to calculate the returns from a mailing campaign, and the returns we calculate it through a formula which my friend will give you in a couple of minutes. And the other idea is to develop a model which helps us maximize the revenue and apply it every year, not just once, but over the period. So, purpose of this analysis. Uh, this project serves as a practical learning experience in understanding the different applications and methodologies used in data mining, and we also use learning the business intelligence using a real world example. We have discussed a lot about data mining. What is data mining? Data mining is every organization has data with them. They have historical data from over many years, which is sitting in their databases. So we are taking the data and analyzing the data to find different interesting patterns which might help the organization in future. So finding a meaning in the data which is initially not obvious, using statistical algorithms and different tech tools and techniques. We use these techniques uh, to make optimal use of large databases. My friend Sai Madhav will take you through the next couple of slides where he'll discuss different modeling types. Sai Madhav.
Yeah, thanks, Amarnath, and good afternoon, sir. Once again, I'm Sai Madhav, and now I'll be proceeding with the different modeling types we have decided to do the analysis on the PVA data. So initially, to be frank, we were a bit confused with which software to be used. We've gone through IBM SPSS Modeler and IBM Cognos and everything, and what we thought was, uh, why not we use SAS Enterprise Miner, which we haven't used it till now. So out of our own interest, we have done a small research on how to work with the Enterprise Miner, and under Enterprise Miner, we came up with three topaz models, like They are logistic regression, decision tree, and the neural networks. So the final conclusion is like we have worked on these three models: the logistic regression, decision tree, and neural networks in SAS enterprise manner. So coming to the data cleaning and the feature selection process, initially the PVA data set we have had 481 variables, and we have done two versions of data cleaning on this 481 variables, and in the initial level we have brought down the variable number to 112, and in the final stage we have reduced them to 34. So going to the data cleaning process in a more detailed manner. Initially, like we have gone through the data dictionary in detail, and we got familiar with the various variables available in the data set. And what we observed is like the previous data set has got each and every demographic details of 13 million people in USA. So which included so many variables like photography, pets, hobbies, etc. And what we thought was like they are not our field of interest to work with to come up with the potential donors. And so in the first version, like we have eliminated those variables and brought the data set to 112 variables. And when we have observed the remaining 112 variables, which were almost like our point of interest, like some of the variables had more than 60% of the empty values, and when there are more than 60% of the empty values, it's of no use to use the state data set. So in the second version, initially we have eliminated those variables which have got more than 60% of the data missing in them, and later on, for the remaining variables, like some of the variables had few values missing, few records missing, which were less than 60%, and we have filled them with the appropriate data, and uh, we have for all this process, like we have used the Excel to work with. So at the end of the day, we came up with 34 variables to do our analysis. Coming to the assumptions, uh, as explained by Amarnath, each mail sent to the donor by TVA costs $0.68, which is 68 cents. And to get the revenue, we have made an assumption of like each donor would donate an amount of $10. So, and we came up with a formula for calculating the revenue earned by TVA, which is equal to true positives into 10 minus false positives into 0.68, where the true positives are the number of potential donors who donated the money, false positives are the number of potential donors who did not donate the money, and 10, as explained to you earlier, that's the assumption we have taken, the $10 amount donation by each donor. And coming to 0.68, it's the cost incurred by TVA to send the mail to donors. And I would like my friend Shivkant to continue with model building and evaluation. Thank you.
Thank you, Sai. Good afternoon, sir. I would like to go through some of the modeling techniques that we have used for the project. And like we actually mentioned before, we have used three models to be built for the project, and those three are logistic regression, decision tree, and neural networks. So coming to logistic regression, and our point of interest here is a binary variable that is target p. That is our target variable. It has a response 0 or 1. And we have a lot many number of predictors that can be used around 34 variables. So and they are all categorical or continuous variables. But our point of interest here is the target p, which is a categorical variable. So logistic regression handles all the categorical variables, and it is a very robust model to be used for such purposes. So we used that for our project, and we came up with some true positives, false for positives here, as you can see. So what is the true positive? Like we know, true positive is nothing but our model predict that a donor would actually donate the amount, and in reality he donates the amount. And false positive is our model actually donates it actually predicts the donor donate the amount, but in reality it doesn't. So we are more interested in the true positives side. and we came up with 170 here, and we've gone through the assumption and formula before, and taking $10 as a revenue for one positive, true positive, and 0.68 to mail to a person, and in return receiving nothing in case of false negative, and substituting those values in the formula, we get a revenue of around $1,608. And coming to the decision tree, the second best model of our analysis that we used for the project. Here we have 139 true positives and false positives to be 92. And the main idea is to actually maximize the true positives and minimize false positives. And again, putting these values, substituting these values in the formula, you get the revenue of $1,327. Coming to the third model that we have used for the project, that is silver and pearls, we come up with true positives of 132 and false positives of 106. And we actually came up with $1,247 according to our formula. So we know that now logistic regression that we use is the best model that generates the highest in terms of the revenue for BBM. So the model comparison, and so far we've been talking about only the false positive and true positives side of the model comparison. But we also look for the AIC value, that's AIX information criteria statistic value, which should be very less for a model to be robust and to actually be used for various data in various data prediction purposes. So in our project, we came to know that logistic regression model has the least AIC value, statistic value of 2.796. Though we added so many variables in our project, we use around 34 predictor variables and by the target variable. We came to know that logistic regression model has the least AIC value compared to decision tree and neural network. From this statistic, we can say that our logistic regression model is the best that we came up and we developed for TVPM. And just would like you to just have a look at this diagram that we actually use in SAP Enterprise Minor. We use the city models here, and we came up with different results. And you can see the validation data here. You can see the training data. Training data, we use 30% of our actual data as training data and 70% as validation data. After we developed the model, we actually checked that it is actually robust across the validation data as well. And we came up with these false positives and true positives that we actually explained before. So what are the lessons learned here? So lessons learned is data mining. We know that data mining is a very complicated process. It is not as easy as it seems, and it requires a lot of statistical background and a lot of patience and experience too. And tools are very complex. We've been using SaaS Enterprise Guide, and in our assignments we've been using IBM Cognos, IBM SPS Model, and for the project we use Enterprise Miner. And there are a lot of tools, but they're kind of complex, and one needs to have a great depth in knowledge to know and understand the tools and apply them properly in the project. And it's a steep learning curve that we have actually made and through our journey. And low representation of target value, it basically means that in the real world scenario, we just expect 2 to 3% of response rate from our mailing campaigns or any other marketing strategies. So with that 2 to 3% that we actually achieve as a response rate, we need to optimize the results and come up with better results, and we need to predict the model perfectly so that the response rate would go up the next time around. And it requires a lot of knowledge and time and experience for that. Okay, coming to the conclusion, like we said, we've been going through some of the slides, and we know that logistic regression model is the best. We came up with logistic regression model and we developed it, and it predicts the best and most productive donors for PBA. Yeah, in terms of the true positives, and we can actually optimize the revenue for PBA, which is the whole cause and goal for the project. Thank you, and we would like to have any questions from your side that we would like to address. Thank you.
Thank you, Dr. Ahmed.